Hello people, this is Bharani from Edureka, and this session is all about data mining. We'll start off by understanding the core concepts of data mining, following which we'll have a hands-on session with R. Let's have a look at the agenda. We'll begin this session by knowing what is the need of data mining. Thereafter, we'll comprehensively understand what exactly is data mining. Next, we'll learn about the sequential steps involved in extracting knowledge from the data. Further, we'll go through some of the most common data mining techniques. And then we'll look at the list of programming languages which can be used for data mining. Finally, we'll arrive at the most interesting part of the session, which is a case study using R. Why data mining? As they say, this is the age of information. And for information, we need data. Let's take an example. You go out with your friends for a party, take some selfies, and then upload these selfies on Facebook. Look at the bigger picture now. Not just you, there are millions of people uploading millions of selfies every single day. And this is the data deluge that I'm talking about. Data is everywhere and it is expanding exponentially. And this data is being generated from multiple sources. This is not just coming from social media. It comes from sectors such as healthcare sector, financial sector, telecom sector, and so on. And this data is also available in multiple formats. Let's have a quick look at the different data types we have. Broadly speaking, we have structured, semi-structured, quasi-structured, and unstructured. Structured data type has a defined format, and since it has a defined format, extracting information from it is quite easy. Semi-structured data does not have a rigid pattern, but it does have a noticeable pattern. An example of semi-structured data would be the XML file. Quasi-structured data, it neither does have a rigid structure nor does have a noticeable pattern, but with a bit of tweaking, information can be extracted from it. Unstructured data has no inherent data format at all, and that is why extracting information from it can be quite a cumbersome task. We've understood that data comes from multiple sources and it is also available in different formats. Now let's see what can be done with the data which we have with us. This is John, and he comes across financial data, and he's trying to understand how many of these financial transactions are fraudulent. Now John stumbles upon the email data and he's trying to figure out how many of the mails are spam. John notices telecom data and he wants to find out how many of the customers will churn out. John does have the data with him. How does he obtain information from it? So his friend Jim is a data scientist who suggests him to use data mining techniques to find solutions to each of the three problem statements. That is, John can use data mining techniques to find out how many of the financial transactions were fraudulent. Similarly, he can also use data mining techniques to find out if the mail was spam or not. And again, John can again use data mining techniques to find out how many of the customers will churn out. We've understood the need of data mining. Now let's understand what exactly is data mining. Let's look at the definition. Data mining is the computing process of discovering patterns in large data sets involving methods at the intersection of machine learning, statistics, and database systems. Now that is quite a complicated definition. So what do we exactly mean by that? In simple terms, data mining is mining of information from data which is new, correct, and potentially useful. Now let's understand why should the mined information be new. Let's take an example. We have a data set with us. We apply some data mining techniques, find out a pattern, and this pattern tells us that smoking causes cancer. Now, this is not something new. We already know this. We've invested time, we've invested effort, and we've found out information which we already know. So it doesn't really serve a purpose. Let's look at the next parameter, the correctness of the information. Let's again take an example. We have a data set which comprises of the stock prices of all the companies. And we predict that a company X, its stock price will increase by 20% in the next week. But on the contrary, what actually happens is its stock price decreases by 10%. What happened over here? We found out information which eventually proved to be wrong. And that is why it is always necessary to check the validity of the information before we reach to any sort of conclusion. You understood that the information is new and correct. Now it's time to see if the information is useful or not. As we saw in the first example, we found out an information which told us that smoking causes cancer. Now, that information did not serve a purpose. So instead of finding that information, what we can do is we can find out patterns which would tell us the longevity of a person who smokes and the longevity of a person who does not smoke. This information will be more useful to us. You understood what is data mining? Now let's look at the sequential steps in discovering knowledge from the data. KDD has these steps: selection of data, pre-processing of data, mining of data, evaluation of patterns, and representation of knowledge. Let's start with the first step, which is selection of data. We already know that data comes from multiple sources and that is also available in multiple formats. So our first task would be to integrate all of this data and store it in one single location, which is the data warehouse. So we've integrated the data, stored it into a data warehouse. Now we can select one particular data set on which we would want to do our analytical tasks. The data selection has been done. Now it's time to do some pre-processing. Pre-processing tasks involve such as understanding the structure of data. We can also use visualization techniques to understand how are the variables in the data set related to each other, the correlation among them. We can also apply simple operations such as summarizing, aggregation, and normalization. Data selection has been done. We've also done a bit of pre-processing. Now it's time for the most important step in KDD process, which is mining of data. You already know what is data mining. Now let's understand how can we do it. So data mining is applying of intelligent operations such as clustering, classification, regression, and so on. We apply these intelligent operations and extract patterns. So we've applied intelligent operations, we've obtained patterns. Now it's time to check for the validity of these patterns. That is, we do the three parameter check. We need to see if the obtained information is correct, useful, and new. Once the information is validated, now it's time to finally represent the information using simple and aesthetic graphs. So those were the sequential steps involved in KDD process. Now let's look at the data mining techniques. In this session, we'll be looking at anomaly detection, association rule mining, clustering, classification, and regression. Let's proceed with the first data mining technique, which is anomaly detection. This technique helps us to identify unusual patterns or outliers in the data. Let's take an example. There's a movie theater, and the average salary of people who go to watch a movie in that theater is around rupees 50,000 per month. One fine day, it just happens that Mr. Mukesh Ambani decides to watch a movie in this theater. So what happens? The average salary shoots up, and it shoots up sky high. So in this case, Mr. Mukesh Ambani would be the outlier or the anomaly. Prior to processing of the data, we need to make sure that we do some processing on the outliers. That is, either we remove the outliers or we do a bit of adjustment to the outliers, and then we come to the main analysis part with the data. The next technique is association rule mining. This is also known as market basket analysis. This has a very interesting example, and it goes by the name of the Biodiaper syndrome. So in a survey done by a supermarket, it was found out that whenever a single father came to the store to buy a diaper, there was very high likelihood that he would also buy a bottle of beer. Now that's quite an uncanny relationship, isn't it? A single father coming to a store to buy a diaper also buys a bottle of beer. Quite strange. But this is what the supermarket was able to find out with the help of association rule mining. And this is also the basis for many of the recommender systems. Let's take Netflix. Suppose you watch the TV show Friends on Netflix. The recommender system also suggests you to watch How I Met Your Mother and Big Bang Theory. Why does it do it? The recommender system understands that all of these three TV shows belong to the comedy genre, and therefore, if you watch Friends, there is also a high likelihood that you might watch Big Bang Theory and How I Met Your Mother. Next comes clustering. This comes under the purview of unsupervised learning. So, with the help of clustering, if we have a set of observations, we can segregate these observations into clusters on the basis of their similarity. Let's have a look at this slide. We have this set of observations and we are obtaining two clusters from these. So the first cluster comprises of all the animals and the second cluster comprises of all the birds. And this clustering has been done on the similarity of the observations. That is, there is high intra-cluster similarity. So what do I mean by high intra-cluster similarity? That is, all the observations in one cluster are similar to each other. So if we see over here, all of these are animals and they're similar to each other. And in the second cluster, all of them are birds and they're quite similar to each other. But when we compare these two clusters, what happens is there is very low similarity or there is quite a bit of dissimilarity. And this is the basis for clustering. Now I've said that clustering comes under the purview of unsupervised learning. So what is unsupervised learning? Now again, unsupervised learning comes under the domain of machine learning. And machine learning algorithms are algorithms which learn on their own. So coming to unsupervised learning, they do not have predefined labels. So what we see over here are, we just have observations and there are no labels which tell us that this is an animal or this is a bird. But even then, the unsupervised learning algorithm is able to cluster them. And the clustering has been done on the basis of similarities of these observations. It is only after the clustering has been done that we understand that all of the observations in the first cluster are animals and all of the observations in the second cluster are birds. The next technique is classification. And classification comes under the purview of supervised learning. And in supervised learning, we do have predefined labels. So let's take a look at the slide. We have an observation and we have two labels, which are cat and dog. And our task is to assign a label to it. So what are we doing over here? So what happens in classification is we have an observation and we try to classify it into one of the categories. So for this slide, if we assign the observation the label of cat, then the classification would be wrong. If we assign the label of dog to it, then the classification would be right. The next technique is regression. With the help of regression, we can find out how does one variable change with respect to another variable. Regression again comes under the purview of supervised learning, and therefore we have labels. There are many types of regression techniques such as linear regression, logistic regression, Poisson regression, and so on. And for the sake of this session, I'll give a brief intro to linear regression. Now all of you must have come across the equation of a straight line, which is y is equal to mx plus c. Over here, y will be the dependent variable and x will be the independent variable. And we are trying to understand how does y vary with respect to x. That is the basic idea behind regression. So we have one dependent variable and we try to understand how does this dependent variable change with respect to the independent variables. We've looked at some of the most commonly used data mining techniques. Now it's time to have a look at some of the programming languages used for the purpose of data mining. We have Jim again, and Jim tells us that we can use R, Python, Julia, and SAS for our data mining tasks. And for the hands-on, since I've used R, let's understand some of the features of R. Or why am I using R? So R is a programming language which is used for many statistical modeling and data science tasks. And I believe one of the best feature of R is that it provides more than 10,000 free packages. So whatever your need is, if you want to do data visualization, R provides a package for that. If you want to do statistical analysis, R provides a package for that. If you want to do data manipulation, R also provides a package for that. Isn't it great? Now, R is also a dynamically typed programming language. What do I mean by it? So the focus is on the value of the variable and not on the data type of the variable. So because of this, we can make statements in R such as So the first statement would be A is equal to 10, and the next statement would be A is equal to AND. So we see over here that the focus is not on the data type. For the first case, we are assigning an integer, and for the second case, we are assigning a string. And this is the basic idea of a dynamically typed programming language. Another feature of R is it can be easily integrated with other popular softwares. Some of the examples are Tableau and SQL Server. You understood why R? Now let's look at who uses R. So this slide tells us that the big shots, the top-notch companies use R. Facebook uses R for behavior analysis, Google uses R for advertising effectiveness, and Twitter uses R for data visualization. So if your idea is to do some data science tasks, then R is definitely the programming language that you need to use. So you understood why R, who uses R. Well, let's finally go ahead and install R. So this is the site from where you'll be installing R, cran.r-project. Let's go to the cran repository. So I'll just type out download R over here. I'll click on the first link. If you have a Windows system, you can download R for Windows. If you have a Mac, you can download R for Mac. If you have a Linux, you can download R for Linux. Since I have a Windows system, I'm downloading it for Windows. And this is the latest version of R 3.4.2. I click on download and the download starts. Now we also have an IDE, which is RStudio. Now I'd recommend all of you to also download the IDE before you perform programming because RStudio makes our task easier. Let's go ahead and also download RStudio. I'll just type out download RStudio over here. I click on the first link and it redirects me to rstudio.com. I download the free version and these are the options: Windows, Mac and Ubuntu. I download it for the Windows system and download starts. Now since I've already installed R in RStudio, I don't need to install it again. So we'll directly go ahead to the case study. This will be our case study. We have the houses for sale data set, which comprises of price of house, lot size, number of rooms, living area, and so on. And our task is to understand the data set and design a model which will help us to predict the prices of houses with respect to other variables. Let's look at the tasks which we'll be performing in the case study. We'll start off by importing the data set and then we'll do a bit of pre-processing. So the pre-processing will consist of understanding the structure of data, and it will also involve a bit of data cleaning because the data would be untidy. So we're supposed to make it tidy. Then comes the important part, which is data mining. And the data mining technique which we'll be using is linear regression. So we'll use linear regression to predict the prices of houses. And we'll be building two models actually. And out of those two models, we'll try to understand which model is more accurate or which model will give us better results. Let's start with the hands-on session. This is RStudio and this is how it looks like. This is the script window, this is the console window. Let's start with the first step. So read.csv, this is the function with which we are importing the CSV file. And that CSV file consists of the houses dataset. Let's look at this dataset. This is the dataset, guys. So these two columns are so purpose, they just are numberings. So we would have to delete them. This is the price of the house. This is the lot size. This column tells us if the house has a waterfront or not. This column tells us how old is the house. This is the land value. This column tells us if the house is newly constructed or not. And this is for if the house has centralized air conditioning or not. These two are the fuel types and the heat types used in house. This is the sewer system, living area, the number of fireplaces, number of bathrooms, and number of rooms. That is the data set. Let's also look at the structure of the data set. str function, with the help of str function, we can understand the structure. Now this tells us there are 1728 observations and 16 variables in total. And most of these variables are of the type integer. That was the structure. Now we've understood that this data is not clean. So let's go ahead and do the pre-processing or a bit of cleaning. So the first task would be to delete these two columns. After that, now these values seem to be a bit ambiguous. So if the house has a waterfront, we can change it to yes instead of 1. And if the house does not have a waterfront, we can change it to no instead of 0. Similarly, we can change the values to yes and no for construction Similarly, for the fuel type, instead of 2, 3, and 4, we can change it to electric, gas, and air. And again, for the heat type, we can change it to hot air, hot water, and electric. For the sewer system, it again has the values 2, 3, and 4. So instead of 2, 3, and 4, we can make the sewer system type to be private, public, and none. So none will say that the house does not have a sewer system associated with it. These are the basic pre-processing tasks that we would need to do. And for that, we would have to load the deployer package. I'm loading it. Prior to loading any package, we are supposed to install it. I click on install over here. I type out deployer, select it. Now, when I say install, the package will be installed. And since I've already installed the package, I don't need to do it again. I've loaded the package. Now it's time to delete the first two columns. The select function comes from the deployer package, and this is the dataset. And this symbol over here that you see is the pipe operator. The pipe operator helps us to connect things. So from the houses dataset, we are selecting all other variables except the first and the second column, and we are storing the result again in the houses dataset. So we applied the command and we see that the changes have taken place. The first two columns have been deleted. Let's go ahead with the pre-processing. So we saw that wherever the values were 0 and 1, they have been changed to no and yes. Let's again have a look at these commands. So dollar symbol helps us to select the column. So with the help of houses $air cond, what am I doing is I'm selecting the air condition column of the houses dataset. So I select this column and I change it to a factor. That is, initially the values were numerical. Now I'm changing it to a categorical variable. I've changed it to a categorical variable, and now it's time to change the labels of it. So initially the labels were 0 and 1, and I'm changing the labels to no and yes. I've done the same for construction column and waterfront column. So I've selected the construction column, changed it to a categorical variable, and changed the labels to no and yes. I've done the same for the waterfront column as well. Now let's go ahead and also change the fuel type, heat type, and the sewer system. Let's go ahead and do that. So we've changed fuel and sewer. So the fuel type has been changed to gas, electric, and oil, and the type of sewer system has been changed to none, private, and public. We also need to change the heat column. Let's also do that. So I'm selecting the heat column with the help of the dollar symbol. I'll change to hot air, hot water, and electric, and the changes will be applied. Yes, the changes have been successfully applied. We're done with the pre-processing. Now let's start visualization. For visualization, R provides us with a package which goes by the name of ggplot2. And again, prior to loading the package, we're supposed to install it. I just type out ggplot2 over here, select it, and when I click on install, the package will be installed. And since I've already installed it, I don't need to install it again. Now ggplot2 is based on grammar of graphics. Now whenever we are trying to form a sentence, we are supposed to follow the grammatical rules. Similarly, whenever we are making graphs, we have something known as grammar of graphics, and we need to follow this grammar of graphics. Let's understand what exactly is grammar of graphics. So for this command, grammar of graphics has three parts. The first is the data part, next is the aesthetic, next is the geometry. So first we're supposed to select the data set on which we're supposed to do the plotting. So over here I've selected the houses data set. Next are the aesthetics. So aesthetics tell us on what variable are we supposed to map. That is, we can select the aesthetics such as x-axis, y-axis, or the color, or the fill, or the size of it. So these are the aesthetics, and we assign variables to these aesthetics. So for this case, I've assigned the price to the x-axis, and then finally it's time to decide the geometry. That is, the type of graph that we want to plot. We can either select a histogram, box plot, scatter plot, or a line plot. So whatever is our need, we can select a geometry for that. So now I would want to know what is the distribution of price. Let's plot this. I've plotted the graph. Now this is the price distribution. You see these values over here. So this is 2e plus 0.5, 4e plus 0.5, 6e plus 0.5. That basically stands for 2 into 10 power 5, 4 into 10 power 5, 6 into 10 power 5. that again means the value is around 2 lakhs, 4 lakhs, or 6 lakhs, and 8 lakhs. So from this graph, we can infer that the average salary of the houses is around 2 lakhs, and the maximum price of the house would be around somewhere close to 7.5 lakhs. We're done with this. Let's add a bit of color to the plot so that it looks prettier. So in the geometry, I've added two more attributes. I have fill and I have color. So the fill is of light blue and color, which is the boundary, is of dark blue. So the same graph, I just added color to it. Now let's understand how does price vary with respect to waterfront. That is, if the house has a waterfront, what is the price of the house? And if the house does not have a waterfront, what is the price of the house? So the data is again houses. The y-axis denotes price, x-axis denotes whether the house has a waterfront or not, and the color is again determined by whether the house has a waterfront or not. And the geometry used over here is box plot. So the color or the fill is automatically determined by the variable. Since waterfront has two categories, it gives two colors. Let's look at this. So we can easily infer that if the house has a waterfront, it will have a higher price, and if the house does not have a waterfront, it will have a lower price. So we'll be comparing the median values just to be sure. So the median value of the house which has a waterfront is higher, and the median value of a house which does not have a waterfront is lower. Now let's see how does the price vary with respect to the air conditioning. Again, dataset is houses, y-axis is price, x-axis is determined by whether the house has air conditioning or not. The fill is determined by, again, whether the house has air conditioning or not. Geometry used is box plot. Again, we can very easily infer that if the house has air conditioning, its price will be higher, and if the house does not have air conditioning, its price will be lower. Let's see how does price vary with respect to living area. So over here, the geometries used are scatter plot and a line plot. So geom point is for scatter plot, geom smooth is for line plot, and again, x-axis is for living area, y-axis determines the price. So we see over here that it is a linear relationship. That is, as the size of living area increases, the price of the house also increases. Now let's see how does the price vary with respect to the age of the house. Now this is inverse relationship. That is, if the age of the house increases, that is, if the house is old, its price will be low, and if the house is new, its price will be high. This will be a very interesting plot. Quite a pretty plot, isn't it? Again, y-axis determines price, x-axis determines the size of living area, and this over here that you see is that the colors are determined by the number of rooms. So if the house has 5 or 6 rooms, then the price of the house would be around 1.5 lakhs to 4.5 lakhs, because the color of the house, if it has 5 or 6 rooms, is green, and all of these green dots come between 1.5 lakhs to 4.5 lakhs. Similarly, what we can say is if the house has 12 rooms, so it will have the maximum price. So these are the sort of inferences which we can make from this graph. We've selected the data, we've done a bit of cleaning, we've also done a bit of visualization. Now it's time to come to the most important part of the case study, which is applying the data mining technique. Now, prior to building the linear regression model, we're supposed to split our data into training set and testing set. We do this because this helps us to measure the accuracy of the model built. So we build our model on the training set and check for its accuracy on the test set. To split the data set, we're supposed to load the CA tools library, the CA tools package, and again, so prior to loading, we're supposed to install the package. CA tools package provides us with a function which goes by the name of sample.split. Now, this has a parameter split ratio. Split ratio determines how many of the observations get true label and how many of the observations get the false label. So we've given the split ratio to be 0.65. That is, 65% of the observations will have the true label and 35% of the observations will have the false label. And I've stored the result in split index. The splitting is done. So what are we doing over here? Now, wherever the value or the label of the observation is true, we are selecting all of those observations and storing them in the training set. And wherever the value of all the observations is false, we're selecting them and storing them in the test set. So training set comprises of 65% of the observations and testing set comprises of 35% of the observations. Train set has 1273 rows, test set has 455 rows. That is the 65-35 split. We split the data. Now it's time to build the model. We're building linear regression. Now as we saw, the basis of linear regression is a linear equation which is y is equal to mx plus c. So over here, this is the formula. So the tilde symbol, on the left side of this tilde symbol, we have the dependent variable, and on the right side of the tilde symbol, we have all the independent variables. So the price is the dependent variable. And when we put a dot over here, this basically determines that we are selecting all other columns except the price. That is, we're trying to understand how does price vary with respect to all other columns in the data set. And we built the model and stored it in the object mod1. Now it's time to predict on the test data set. So we check for the accuracy of it on the test set and store the result into an object which has the name of result. I do this. Now let me bind the actual values and the predicted values. So the test set has the price column, which are the actual values, and the predicted values are in the result object. So I'm naming it as predicted, and I'm combining these two columns and storing it in an object whose name is compare result. Let me have a look at this. These are the actual values and these are the predicted values. Let's find out the error in prediction. Now since compare result is a matrix, we're supposed to convert it to a data frame using as.dataframe function. I've changed it to a data frame. I found out the error. So we find out the error by just subtracting actual values minus predicted values. So actual values minus predicted values gives us the error in prediction. That is what I've done over here. Let me also bind the error in prediction to the same data set and store it in compare result. Let me have a look at compare result. So actual values, predicted values, and error in prediction. We have something known as root mean square error to check for its accuracy. We store it in RMSE1. Let's look at its value. So this is the error in the prediction. 52837.57 is the error in prediction. Now let's also have a look at the summary of the model built. So this was the model which we built on the training set, and this is the summary. So these stars which you see over here, these tell us how much is the impact of this independent variable on the dependent variable. Greater the number of stars, greater is the impact. So wherever the variable has 3 stars, that would mean it has a greater impact on the dependent variable. So if the house has a waterfront, then it will have a greater impact on the price of the house. If the land value again has a greater impact on the price of the house, and if it's newly constructed, it again has a greater impact on the price. Now let's look at the opposite side, that which do not have an impact at all. So heat, sewer, the number of fireplaces, so the type of heat used or the type of fuel used or the number of fireplaces used, they do not have an impact on the dependent variable at all. We have another check for the accuracy of the model, which is the adjusted R squared. So if this value is closer to 1, then that would mean this model is perfect. So the accuracy of this model is around 0.651. Now let's build another model and compare that model with this. This is the second model. Now since we've understood that fireplaces, sewer, and fuel do not impact the dependent variable at all, so I've selected all other variables except these 3 variables. So you see this minus symbol. So I'm removing fireplaces, sewer, and fuel by putting a prefix minus before it. So I'm storing the result in mod2. I predict the model on the testing set and store it in result2. Now it's time to bind the actual values and the predicted values, and I store it in compare result2. Let's have a look at compare result2. This is compare result2. These are the actual values and these are the predicted values. Let's have a look at the we're supposed to change it to a data frame since it's a matrix. So I've changed it to a data frame using as.dataframe. Now it's time to find out the error in prediction. So I've subtracted the predicted values from the actual values and store the result in error. Now also let's combine the error in prediction to the same data set. Let's have a look at this. actual values, predicted values, and error in prediction. Let's go ahead and also calculate the root mean square error of it. Root mean square error is simple. So we square the error and then we find out its mean and then we find out its square root. Let's compare root mean square error of both the models built. So RMSE1 is 52,837, RMSE2 is 52,773. What we observe from this is the error of the second model is lesser than the error in the first model. And that is why the second model is better than the first model. Let's also have a look at its summary of mod 2. So its R squared value is 0.6522 and the R squared value of the first model was 0.651. And since we see that this value is greater than the first model, again, so model 2 is better than the first model. So this was it, guys, for the case study. We started off by importing the dataset. We did a bit of pre-processing and then we used the ggplot2 package to visualize the correlation among the different data entities, and then we split the dataset. After splitting the dataset, we finally built the linear regression model. We actually built two models. After that, we found out the accuracy of these two models and evaluate which performs better. Thank you for watching it. Hope you enjoyed it. Thank you.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!